What if the brightest guest in our sky is not just another frozen traveler, but a messenger? The comet Three Eyes of Atlas is no ordinary comet. Its trajectory, timing, and dazzling pass by Mars left behind anomalies that are hard to explain. The instruments detected faint vibrations in the dust, whispers of debris that appeared not as chaos, but as intention. Maybe it's a seed of life thrown across the stars, or a weapon disguised as ice. The deeper we dig, the stranger the situation becomes. Today, we will unravel clues, rumors, and horrifying assumptions. For if the Three Eyes of Atlas are not random, then our future is not either. The question hangs in the air. If the rumors are true, how much time do we have left? Stay until the end, for what you will uncover concerns not only the comet, but also ourselves and what may already be set in motion. Part 1. The Last Turn. Something crossed Mars's orbit on October 3rd, 2025, and millions believe they are being lied to about what it was. The object in question is officially called Three Eyes of Atlas, the third confirmed interstellar visitor in our solar system. He came from beyond the stars, taking millions or billions of years to leave that place, and now he races toward the sun with such speed that he would melt any spacecraft ever created by man. The main scientific community claims that this comet is likely just ice and rocks covered in a dusty layer, following the same physical laws as other frozen wanderers in the universe. They claim that the strange readings are artifacts of the instruments, optical illusions, and sensor noise, that we see what we want to see. But then, images were leaked. On October 5th, 2025, a grainy sequence appeared on social media, allegedly captured by the Mars rover Perseverance during its flyby. The video shows a dim stripe moving against a starry field. Nothing unusual for telescopic shooting, except for one detail. This stripe has a structure, with many parallel lines, almost geometric, moving in perfect synchronization. In 6 hours, the post received 17 million views. 12 hours later, NASA released a statement calling it an artifact of processing, a glitch in the image compression algorithm creating false patterns in noisy data. Within 24 hours, 3 more alleged frames appeared from various sources, each showing similar geometric patterns. The internet, as expected, exploded. Astronomy enthusiasts began analyzing all available data. Forums on astrophotography filled with discussions. Someone applied pattern recognition software developed for tracking satellites. The program revealed anomalies that do not prove anything, but are enough to maintain interest and raise questions about why NASA reacted so quickly and defensively if it was just noise in the system. This is what we know for sure. The Three-Eyed Atlas was discovered in November 2023 by the Early Warning System for Potential Strikes on Earth, operating in Hawaii. This is the same network that alerts us to possible threats from space objects. At first, astronomers thought it was just another long-period comet from the Oort cloud, a vast sphere of icy debris surrounding our solar system like a cosmic snow globe. However, as observations accumulated, the trajectory became clear. This object was not from here. Its orbital speed was too high, and its path too hyperbolic. It came from interstellar space, becoming only the third confirmed object of its kind after Oumuamua in 2017 and Borisov in 2019. But the Three-Eyed Atlas differs from its predecessors in important ways. Oumuamua was tiny, only a few hundred meters long, spinning in space like a cigar, or perhaps a pancake, depending on the model you prefer. He showed an unexplainable acceleration upon leaving the solar system, a small push that could not be fully explained by ordinary sublimation. It is a normal process when frozen material on the surface of a comet turns into gas and creates thrust. Scientists proposed numerous natural explanations, from hydrogen ice to cosmic dust pressure, but none fit perfectly. Then it vanished into the darkness behind Neptune before we could study it properly, leaving more questions than answers. Borisov was a more compliant, well-behaved interstellar comet, which looked and acted almost like comets from our solar system. It had a full coma, a diffuse cloud of gas and dust surrounding its nucleus. It had a tail pointing away from the sun, as expected. He followed the rules, and the scholars sighed with relief. The universe became rational again. Now the Three-Eyed Atlas appears, and the rules seem to be changing. Whispers began to circulate quietly in academic circles that something was wrong with the trajectory. Observers noted that the object appeared to maintain stability better than expected, given its size and composition assessment. Some claimed that its speed showed slight variations inconsistent with purely gravitational movement. These variations were small, within the margin of error, but they existed. Or perhaps they did not. The margins were broad enough to conceal many interpretations, and this is what makes the moment so explosive. Then came the mass estimates, and the situation became more complicated. Initial calculations suggested that the three-eyed atlas could be significantly more massive than initially thought, possibly orders of magnitude heavier than Oumuamua. If so, everything changes. A heavier object requires more force to change its trajectory, making any anomalies in its path harder to explain in terms of natural processes. This also means that collision scenarios are becoming exponentially more catastrophic, although the current trajectory does not show a potential threat to Earth, at least for now. The flyby past Mars was supposed to clarify some of these questions. Upon closer approach, 3 comets Atlas flew approximately 5 million kilometers from the red planet, allowing several orbital missions to observe them with unprecedented resolution. Mars Express is a veteran orbital spacecraft of the European Space Agency, trace gas orbiter with its modern spectrometers. NASA's mission named Mervon studying Mars's atmosphere. Mars Reconnaissance Orbiter with a powerful high-resolution camera, and even Perseverance on the surface, pointing its camera to the sky. All the main tools of the Martian system were aimed at the object, and then we waited for data. This is where conspiracy theories had a chance. In the age of instant information, any delay seems suspicious. People forget that data transmission from deep space occurs at the speed of light, which sounds fast until you remember that Mars is about 200 million kilometers away, meaning signals take about 11 minutes to cover that distance. Considering the time for compression, processing, calibration checks, and the fact that orbital missions were not designed for rapid astrophotography, delays become inevitable. But inevitability does not stop speculation. The leak of images appeared before the official release, which should have been the first alarming signal. Real scientific data goes through verification protocols before publication to avoid the spread of false positives. But in the court of public opinion, official channels move too slowly. Leaked footage, authentic or forged, filled the vacuum that institutions were too cautious to occupy. NASA's rejection was swift and technical, citing known JPEG compression artifacts, cosmic rays hitting camera sensors, and hot pixels that can mimic structural features in low-light conditions, all of which are absolutely true, occur regularly, and provide perfect cover if you are trying to hide something. But if the rumors are true, how much time do we have? It depends solely on what the Atlas comet is and what its purpose here is. The timeline for survival changes depending on whether we consider a natural comet or something with intent. A comet will pass by, possibly giving us a spectacular show in the night sky, and then disappear back into the darkness. The probe might do the same, serving as a reconnaissance mission gathering data for some distant civilization, or it may have entirely different plans. The clock is already ticking, approaching perihelion. The sun hangs on the horizon. Soon we will know if it was just noise in the system or the first real signal. Part 2. Mass matters. The mass of an object indicates how seriously it should be taken, and recent analyses suggest that we may have seriously underestimated Comet Atlas from the very beginning. Initial estimates placed this object within the range of typical long-period comets, possibly a couple of kilometers in diameter, weighing billions of tons, but nothing unusual by cosmic standards. These calculations were based on brightness measurements combined with assumed albedo values, the reflective ability of the surface. Essentially, you are trying to determine the size of a coal block in a dark room using only a flashlight beam reflecting back. However, as the object approached, 3 Atlas telescopes connected to its trajectory, and something in the calculations began to change. The object turned out to be brighter than expected at certain wavelengths and dimmer at others. When researchers processed the updated data with refined models, mass estimates increased. Some now suggest that the 3 bodies of Atlas may be 10 times more massive than the new Oumuamua, or even more. This changes the entire discussion. A massive object exhibiting any anomalies in trajectory becomes exponentially harder to explain by mere natural gas emissions. The amount of gas needed to alter the course of such a colossal body approaches the absurd. To illustrate this, let's note that the Oumuamua was estimated to be about 100 meters long and 400,000 tons in mass. At such sizes, the inexplicable accelerating force it exhibited could theoretically have been caused by the release of hydrogen ice. The mathematics was awkward, but possible. Now let's consider three Atlas AIs. If the current estimates are correct, and we are dealing with an object weighing tens of billions of tons, the amount of gas needed for even minor trajectory adjustments becomes colossal. You will need to produce material in such volumes that it will be visible to every telescope pointed in that direction. The coma must be enormous, and the tail impressive. Some of this is indeed observed. A coma and tail have formed around the three moons of Atlas. Certainly, but the connection between the observed gas emission and the stability of the trajectory seems to be a mismatch. It resembles watching a cargo ship maneuvering in the port without visible tugs. The math doesn't quite add up. The question of density becomes critical. What is the three-eyed Atlas actually made of? A weak pile of stones could have a relatively low density, perhaps twice that of water, which corresponds to typical comet nuclei. But if this object packs mass in a smaller volume than cometary materials would allow, we are talking about something fundamentally different in composition. It is suggested that it could be metal, not pure metal, but a core of metallic material surrounded by an icy shell. Imagine it as a cosmic armor, a protective layer that allows a dense internal structure to survive the journey through interstellar space. There are natural asteroids rich in metal, remnants of destroyed planetesimals. An interstellar asteroid would not be impossible. But the interstellar asteroid, disguised as a comet, begins to sound more like engineering than astronomy. Speculative voices on the network picked up the idea of an engineering shell, a deliberately constructed outer shell designed to mimic a natural comet and protect internal payloads during a journey measured in millions of years. Scientists proposed similar concepts for interstellar probes using ice shields to protect sensitive instruments from cosmic rays and hydrogen atoms, which become deadly projectiles at relativistic speeds. The term mobile asteroid ship has entered common usage, combining the protective mass of an asteroid with the deliberate trajectory of a spacecraft. In this model, the 300th Atlas was built, or at least modified, using a captured comet core as the raw material. The icy component serves as a reactive substance for extremely long propulsion, while the stone components provide structure and protection from radiation. The trajectory data indicates unusual stability. An object moving through space experiences tiny but accumulating forces from solar radiation pressure, gravitational disturbances, and even resistance from the sparse interstellar medium. For millions of years, these forces must change trajectories, making precise targeting nearly impossible without course corrections. The 300th Atlas arrived on a path that will take it past Mars, then past the Sun, and back into interstellar space. Although the accuracy is not perfect, it is better than one might expect from randomness. Either he was incredibly lucky, or someone tipped him off. The inaccuracies create space for interpretation, which explains why this remains merely a hypothesis rather than science. But if we take the mass estimates seriously, if it really is billions of tons, somehow maintaining stable flight in interstellar space, then the engines required for even minor adjustments become colossal. We talk about propulsion systems capable of moving mountains, even if they only make small changes over millions of years. This raises the question of where this energy comes from. Solar panels won't work in the phase of interstellar cruising, when starlight is nearly absent. Nuclear fuel has a limited lifespan of thousands or millions of years, unless the energy source is the sun itself, waiting ahead like a cosmic gas station. Here, suspicion about time arises. The 300th Atlas approaches perihelion, the moment of closest approach to the sun, when radiation intensity peaks and available energy is maximized. If you were designing an interstellar probe that needed to conserve energy for 1,000,000 years, you would aim to reach the destination in a low activity state, and then use solar energy to activate the systems. You would synchronize your arrival to maximize solar radiation while minimizing risks from heat and radiation. Perihelion is precisely that moment. If the mass tips the scales towards the artifact, then the patterns of activity further intensify the suspicions. A massive object must behave predictably under known forces. If it doesn't, and there are anomalies that can't be explained by gas blowouts or modeling errors, we are left with uncomfortable alternatives. Either our understanding of physics is incomplete, creating the illusion that natural objects appear artificial, or we are dealing with something that is truly artificial while trying to pretend it is natural. The numbers tell part of the story. Billions of tons move through space with inexplicable precision, showing anomalies in composition and developing activities that do not quite meet expectations. What leads from assumptions to obsession is when instruments begin to record things that should not exist. This is where Mars comes into play and why the leak of images is more significant than it should be. If the three-eye atlas is just a comet, Mars should have seen the comet. If it's something else, Mars should have seen something different. And if Mars noticed something else, but we are told he saw a comet, then the real question is not what a triad atlas is. The real question is that someone doesn't want us to know. Part 3. Mars. Meeting. Who saw what? October 3rd, 2025 was supposed to be an ordinary opportunity for observation. It's the kind of coordinated campaign that happens every time something interesting passes through the inner solar system. Instead, it became the center for all conspiracy theories about hidden truths and institutional cover-ups. The flyby of Mars was simple from an astronomical point of view. 3 Atlas probes passed at a distance of about 5 million kilometers from the red planet at the moment of closest approach, close enough for high-resolution observation, but far enough to eliminate the risk of collision. Each operational orbital mission received target observation coordinates several weeks prior and allocated observation windows accordingly. Mars Express aimed its high-resolution stereo camera at the sky during the flyby windows. The gas tracer orbiter captured spectra in search of mission and absorption lines that reveal the chemical composition. The NASA MEVEN mission conducted basic photometry, measuring changes in brightness over time. The high-rise camera of the Martian Reconnaissance Orbiter, one of the most powerful cameras beyond Earth's orbit, was supposed to capture something unusual during its flyby. The Perseverance rover's cameras were aimed at the sky during the predicted windows. In total, about a dozen instruments from several missions were monitoring the 3 Atlas during the encounter with Mars. Together, they represented humanity's best chance to observe the object up close using existing resources. Then we waited for the data to arrive. It is here that misunderstanding turns into suspicion. The connection with distant space operates on physical timelines, not on internet timelines. Earth and Mars are currently about 200 million kilometers apart, which means signals traveling at the speed of light take about 11 minutes one way. This inherent delay cannot be eliminated by any engineering solutions. Add data compression time. High-resolution images are huge files by spacecraft standards, requiring hours for transmission. Don't forget to account for calibration time. Raw data from spacecraft arrives with instrumental signatures, noise patterns, and distortions that must be corrected before the images become scientifically useful. Add to this the coordination protocols between several space agencies, each with its own data publication policies. All this means that the usual delay between observation and public release can stretch to several days or even weeks for complex measurements. For a person accustomed to smartphone photography, where every image can be instantly shared, this seems like a delay in the process, but in reality, it is just physics and bureaucracy moving at their usual slow pace, optimized for accuracy rather than speed, unless someone decided to slow everything down even more. An image leak occurred on October 5, 2025, 2 days after the flyby. They were allegedly obtained from the Perseverance Raw Image Archive. The frames show a dim stripe moving against the stars, aligning with expectations of a distant object crossing the field of view. However, this stripe reveals parallel lines, almost like on a ruler, arranged too evenly to appear random. NASA's reaction explained this with compression artifacts, particularly the boundaries of JPEG blocks that can create artificial straight lines in images. This is, indeed, a real phenomenon. The problem with this explanation is that supposedly the images of Perseverance do not use JPEG compression. They are stored in PNG format, which applies lossless compression and should not create block artifacts. When this discrepancy was pointed out, the official explanation changed to hot pixels, individual elements of the detector that give false readings. Hot pixels are real, but they usually appear as dots, not parallel lines. To create a visible pattern in leaks, several hot pixels must align perfectly in a line, which is unlikely, but not impossible. The third explanation referred to cosmic rays, high-energy particles from space that hit camera sensors and create bright streaks. Cosmic rays indeed create streaks, but they are random, forming at any angle. The parallel alignment observed in leaks would require multiple cosmic ray hits at nearly identical angles in one exposure, which is already on the verge of coincidence, but does not completely violate it. Each individual explanation is plausible, Together, they suggest that explanations are tailored to observations rather than predicting what should emerge. This fuels conspiracy theories. When authorities offer several changing explanations of the same phenomenon, it looks like a search for a story that will work rather than a message of truth. Amateur analysts jumped on the inconsistencies. Numerous forums meticulously dissected the leaked footage pixel by pixel. Some claim to have found additional structures beyond the original parallel lines, geometric shapes that natural compression artifacts should not produce. Others found nothing, seeing only noise that human pattern recognition systems interpret as something significant. The debates quickly turned into tribal disagreements. Some groups were convinced they were witnessing evidence of an artificial structure, while others believed they were observing a mass illusion in real time. Neither side could definitively confirm their viewpoint because they only had access to degraded copies of the original raw sensor data circulating on the internet. Meanwhile, the official processed images from the Mars missions remained undisclosed. Several days passed, then a week. The European Space Agency updated the Mars Express data archive with new observations made in early October. However, the specific frames from October 3rd, depicting 3 eyes of the Atlas, were not included in the update. NASA's archive showed gaps in the predicted flyby windows, which could mean the observations failed. The data was still unprocessed, or files were delayed for scientific publication, among other possibilities. Silence created a vacuum that was instantly filled with speculation. Why are there no images if everything was fine? The most boring answer is that successful observations require more processing time before publication, while unsuccessful observations may not be worth publishing at all. If tracking has failed, or the tools did not capture usable data, there is no conspiracy theory, just operational reality. But dull answers do not explain why preliminary results are not announced. A simple statement like, "The observations were successful, processing continues, expect data publication in 2 weeks," would instantly dispel most conspiracy theories. Instead, we receive silence that fuels the narrative of something unexpected happening and someone deciding how to cope with it. The most troubling possibility is not that something anomalous has actually appeared in the images from Mars. Several instruments independently observed the same anomaly, creating a pattern that is too consistent to be dismissed as a device error, yet too ambiguous to confirm its artificial origin. If Mars Express, Trace Gas Orbiter, and Mars Reconnaissance Orbiter all recorded similar geometric patterns during their flybys, then we are not talking about camera malfunctions. We are discussing something real detected by several independent sensors, and this something may still be natural. Comets can develop jets of emissions, creating structures resembling clouds. The dust and gas in these jets can form linear shapes under certain lighting conditions. Clouds of fragments from recent disruptions may appear as parallel trails. There are natural explanations that can create geometric shapes without artificial causes, but these explanations must be verifiable based on factual data, which brings us back to the issue of data accessibility. When data remains behind closed institutional walls, even for legitimate reasons, it creates an illusion of access control, and in today's environment, appearance often matters more than reality. The history of government responses to potential contact with extraterrestrial civilizations is untrustworthy. During the encounter with Oumuamua, it was later revealed that the Defense Department's tracking systems continuously monitored the object, collecting high-quality trajectory data that remained classified for several months. The final public report revealed nothing particularly suspicious, yet the mystery hinted that the authorities at least considered unnatural explanations. If similar protocols are implemented for 31 atlases, we won't know about it until much time has passed, if we ever do. The presence of classified observations does not prove the existence of conspiracies. It is merely operational security around sensitive monitoring capabilities. However, operational security and true secrecy look the same from the outside. We find ourselves in a situation where numerous instruments observed 31 atlases as they flew past Mars. Data transmission occurred according to standard protocols. Processing continued on regular schedules, yet the vacuum of official images became the main topic. Speculations had already gone beyond control. What if the first contact of Mars with an interstellar visitor turned out not just to be a scientific opportunity, but an operation to gather intelligence from something that knows how to avoid obvious warning signals? What if the geometric patterns are deliberate signals? What if the delay is not due to processing time, but rather institutional debates about information disclosure and the public's right to know? Or what if it's just noise, compression artifacts, and hot pixels, while cosmic rays create phantom patterns as the real 31 Atlas passes by completely ordinarily, and we chase after ghosts born from dreams? The truth is likely contained in this data, waiting to be revealed, ordinary or extraordinary, depending on what the camera actually captured. Until then, we remain spectators, watching a cosmic theater where the curtain has not yet risen, and each delay makes us more certain that something is wrong. The question is not whether Mars saw something during the 31st Atlas flyby. We know Mars saw something. The question is whether what Mars saw matches what we were told, or if the universe has become more complex than any of us were ready to admit. Part 4. Coma, Tail, and Strange Chemistry. Telescopes around the world and in orbit analyze 31 atlases using spectroscopy. This technique allows the separation of light into its constituent wavelengths to determine the chemical composition. What they find does not quite match the typical comet signal, causing quiet concern in astronomical circles, even though official statements confidently support normalcy. The James Webb Telescope directed its infrared gaze at 31 Atlas. At the end of September 2025, capturing spectra during several observations, preliminary results showed strong carbon dioxide emissions, as expected when frozen carbon dioxide sublimates directly from ice into gas under solar heating. But the ratios were wrong. The carbon dioxide signal turned out to be stronger than the models predicted for an object located 30 astronomical units from the Sun. At a distance of about 2 astronomical units, comets typically display water vapor as the dominant substance, while carbon dioxide plays a secondary role. In this case, carbon dioxide seems to take on the main load, dominating the spectral signal so much that it may indicate an unusual composition or anomalous thermal characteristics. One explanation lies in the presence of subsurface reservoirs of pure carbon dioxide, which can be stored closer to the sun than the more volatile water ice and then explosively released when exposed to solar radiation. Perhaps 31 Atlas formed in an unusually cold or carbon-saturated environment, giving it a composition on the edge of the normal distribution. Carbon dioxide may not come from the sublimation of ice, but arise from chemical reactions with surface materials exposed to solar radiation and cosmic rays. This would explain the unexpectedly strong signal without the need for exotic composition, but would also indicate surface chemical reactions not previously observed in solar system comets. Moreover, at the end of September 2025, observers from Earth noted something strange. The coma around the 31 Atlas had a distinct green hue, visible even in images taken by amateur telescopes, like a thin emerald glow around the central core. Green comets are not unusual. This color usually arises from diatomaceous carbon, molecular fragments formed when sunlight breaks larger carbon compounds in the coma. However, the green of 31 Atlas seemed too intense for the brightness and distance of this object. Some spectra also hinted at the presence of cyanogen, another carbon-nitrogen compound contributing to the green coloration. The presence of cyanogen in detectable amounts raised questions about the nitrogen content. Where did the nitrogen come from? Comets do contain nitrogen compounds frozen in their ice, but usually in trace amounts. The 31 Atlas seemed to emit nitrogen-containing molecules in greater volumes than typical comets. The chemistry of nitrogen is important as it is linked to potential biological or prebiotic processes. Amino acids require nitrogen. Nucleotides include nitrogen atoms in their structures. A comet rich in nitrogen, arriving from interstellar space, could theoretically carry complex organic molecules, possibly even chemical precursors necessary for the emergence of life on suitable planets. Or she could carry something that had already transitioned from chemistry to biology, preserved in a frozen state for travel. Truly, strange chemistry was revealed in the detection of trace amounts of metals. Several observant teams reported spectral lines corresponding to nickel atoms in the comet. Nickel emission had already been recorded in comets of the solar system before, so its presence does not raise immediate alarm. However, its quantity seemed off. At the triple comet Tri-Atlas, the nickel signature turned out to be more pronounced than the iron one, which contradicts expected cosmic patterns where iron is usually 10 times more abundant than nickel. Several possible explanations were proposed. Perhaps nickel is concentrated in surface materials that are primarily ejected in the early stages of activity. Maybe iron is present but not excited to the same emission lines, making it less noticeable despite its greater volume. Or the 3I Atlas contains anomalous metal deposits that reflect formation conditions radically different from anything we know about our solar system. Nickel-iron alloys are formed as a result of the differentiation of bodies, planetesimals large enough to melt internally, allowing heavy metals to sink to the center. When such bodies are destroyed in collisions, fragments of the metallic core become metal-rich asteroids. A shard of the shattered core traveling through interstellar space will definitely show unusual metallic signatures. However, the cores do not contain ice. They are made of solid metal and sulfides, not volatile substances that create cometary activity. To demonstrate both high metal content and significant gas release, a hybrid structure is required, a metallic core surrounded by an icy mantle. This is theoretically possible as a result of a collision or can be artificially created. A metallic framework surrounded by an icy shell for a long journey between the stars adds another layer of mystery. 3 Atlas AIs developed both types of tails, as expected, wide and diffuse with a characteristic fan-shaped form arising from escaping dust. However, in some images taken at the end of September, observers noted that the iron tail appears to be slightly deviating from the ideal anti-solar position, bending at angles that do not match the expected solar wind conditions. Iron tails are sensitive indicators of local space weather conditions, reacting to changes in solar wind speed, density, and magnetic field strength. What appeared anomalous could simply be the reaction of Tri-I Atlas to solar wind structures that we had not directly measured during the observational windows. Nevertheless, some researchers noted that the geometry of the tail seems incorrect, even considering the known variations of solar wind. Curves appeared in the wrong direction for standard pressures, almost as if the material was asymmetrically ejected from the core rather than simply blown away by the solar wind. If the Tri-I Atlas indeed emits gas asymmetrically, it could explain the anomalies in the trajectory without resorting to propulsion systems. This would be completely natural, but it would also mean that the object is more active inside than its surface brightness suggests, processing heat and volatile substances in ways not fully visible from the outside. The gas release rates also caused astonishment. For Tri-I Atlas, the observed gas release rates exceeded model predictions by about 20 to 30%, a significant but not impossible deviation. A high degree of gas emissions may indicate that the comet's core is smaller and heats up more efficiently than size estimates suggest. Alternatively, it could indicate that the ice composition is dominated by more volatile substances that can sublimate faster than water ice. All these explanations have a natural origin. However, the high degree of gas emissions combined with unusual chemistry and possible trajectory control begins to create indirect evidence suggesting that something is happening beyond the standard behavior of comets. This is not proof, far from it, but the accumulation of anomalies has become such that dismissing them all as coincidences requires increasingly creative, natural explanations. Then signs of fragmentation appeared. In early October 2025, several observation groups recorded sharp changes in brightness of Comet 3 and Atlas, with brief drops in the light curve lasting from several hours to several days before the brightness level returned to normal. Diminished brightness may indicate the separation of fragments when chunks of the core detach. Comets regularly lose fragments, especially during periods of high activity when subsurface ice turns to gas and builds pressure beneath the surface layers. If 3 and Atlas lose fragments, this is completely normal behavior for a comet experiencing thermal stress, but the fragments also open up opportunities. A broken piece, rotating away from the main core, can reveal its internal structure, showcasing composite textures that differ from its exterior. If the spectroscopy of the detached fragments shows a different chemistry than the main body, it will provide insight into the internal layering. If the fragment reveals an incredibly different chemistry, such as a metallic composition, or molecular structures that do not match natural ice, it will mean that we are not dealing with a comet at all. The overall chemical picture of 3 and Atlas remains unclear, which is the main problem. It corresponds to most expected patterns but deviates in some details, continuing to raise uncomfortable questions. Carbon dioxide is too strong, the green color is too intense, nickel is too prevalent, gas emissions are too high, the tail behaves strangely, fragments may detach. 2 and Boris, the last confirmed interstellar comet, looked completely normal in its composition. Her ordinariness instilled hope, confirming that comets form through similar processes throughout the galaxy. 3 and Atlas do not provide such certainty. She appears mostly normal, behaves mostly normally, but with significant deviations that suggest either a rare, natural variation or something entirely different. And now she approaches perihelion, the moment of maximum solar heating, when everything happening beneath this dusty surface will sharply accelerate. If 3 and Atlas are to reveal their true nature, perihelion will be the moment of truth. But before perihelion arrives, another factor is about to test the object's resilience. A coronal mass ejection from the Sun, a billion tons of magnetized plasma, is on a collision course with Trion and Atlas. A storm approaches, carrying energies capable of destroying a comet or activating a dormant mechanism, depending on what truly awaits in the darkness. Part 5. The collision of the solar storm. The Sun breathes, and sometimes it screams. On October 4th, 2025, solar observatories recorded a powerful coronal mass ejection emanating from active region 3827, a vast cluster of sunspots rotating on the solar disk. This ejection released billions of tons of magnetized plasma into interplanetary space at speeds reaching 2,000 kilometers per second, allowing the distance from the Sun to Earth to be covered in about 18 hours. But this time the Earth was not at the center of the impact, but the comet 3827 was. Coronal mass ejections are one of the most powerful phenomena in the solar system. Explosive releases of magnetic energy capable of ejecting a mass equal to a small moon into space at speeds that can vaporize any man-made material. When plasma clouds collide with planets, they compress the magnetosphere, causing auroras and creating geomagnetic storms capable of disabling power grids and damaging satellites. When they encounter comets, the consequences are even more dramatic, as comets lack a protective magnetosphere. Their bare cores are directly exposed to the storm. Astronomers have already observed how coronal mass ejections interact with comets. In 2007, comet NK passed through a particularly strong coronal mass ejection, and solar observatories captured impressive images of its iron tail completely separating from the core, torn away by magnetic forces and drifting in space, while the comet formed a new tail a few days later. The nucleus remained intact, demonstrating that even direct impacts from coronal mass ejections do not necessarily destroy cometary bodies, although they certainly create significant stress. But 3827 is not an ordinary comet, or at least there is an opinion that it is not. If the hypothesis about the artifact has any basis, a coronal mass ejection represents a natural experiment in real time. How does the object react to a sudden influx of powerful energy? Does it crumble like a weak pile of debris, unable to withstand the stress? Does it repel plasma like a body with unexpected structural integrity? Or does it suddenly begin to glow brightly, ejecting stored volatile substances as a result of an explosive release triggered by energetic particles? If 3827 is a purely natural object, then a coronal mass ejection can cause fragmentation, tearing the core into pieces that will follow diverging trajectories and create a spectacular but ultimately harmless display as the fragments gradually separate. This has happened to other comets during moments of great stress. For example, Comet Nane broke apart, forming more than 20 fragments before colliding with Jupiter in 1994. The Breer comet completely disintegrated in the year 2000, transforming from a single nucleus into a cloud of debris in just a few days. Fragmentation can indeed answer many questions. If 3827 disintegrates and reveals an internal structure not corresponding to natural ice and stone, we will immediately understand that something strange is happening. If the object breaks apart and shows exactly the structure expected from a comet, most speculations about the artifact will disappear. In any case, this will clarify the situation. A coronal mass ejection providing colossal energy in the form of a sudden impulse, electromagnetic fields, and particle bombardment can serve as both a trigger and a source of energy. If you were designing an interstellar station meant to activate the nearest star, you would likely wait for a coronal mass ejection as a sign that solar activity had reached levels capable of supporting operations. The storm becomes a signal of awakening, billions of years in the making, culminating in the moment when local conditions say, "You are home." Ground-based solar telescopes captured images of a coronal mass ejection spreading outward. Phantom coronal structures glowed in ultraviolet light as a billion-degree plasma flow traced the magnetic field lines. Space instruments like the Solar Dynamics Observatory and the Solar and Heliospheric Observatory provided continuous monitoring, tracking eruptions from their onset to interplanetary expansion. These observations allowed researchers to model the trajectory of a coronal mass ejection and predict when and where it would intersect the path of the object, 3I Atlas. The estimated collision time opened on October 6th at approximately 14 hours Universal Time, with an uncertainty of plus or minus 6 hours depending on the speed of the front edge of the plasma cloud. Observatories around the world coordinated their efforts to ensure continuous observation during this window, imaging 3I Atlas in various ranges to capture any sudden changes in brightness, color, or structure. And then we waited again for the data transmission, processing, official analysis to catch up with the amateur speculations racing at the speed of light across social networks. Some amateur observers reported changes in the brightness of the 3 Atlas stars during the supposed collision, sudden bursts lasting from several minutes to hours before returning to baseline levels. Others, observing the same object at the same time, noticed nothing unusual, indicating either that the changes were below the detection threshold for smaller telescopes or that the reports were false alarms, seeing patterns in noisy data that weren't actually there. Professional observations remain mostly undisclosed as of mid-October 2025, still undergoing the usual stages of data validation and scientific review. Однако предварительные заявления некоторых исследовательских групп намекали на интересные особенности. Фраза достаточно расплывчатая, чтобы означать абсолютно все, от потрясающих плазменных взаимодействий до слегка необычных колебаний яркости, или ничего, что звучит разочаровывающе как технический жаргон. If 3 Atlas indeed experienced something unusual during the coronal mass ejection, something that revealed an artificial structure or anomalous behavior, the data exists somewhere in the observation archives. The question is whether they will be published openly or quietly, disappear within the confines of classified analysis, while public announcements continue to emphasize natural explanations. The storm has passed, and the plasma cloud that emerged on October 4th has spread throughout the inner solar system, enveloping Mercury, Venus, Mars, and Earth, along with 31 Atlas along the way. All interactions have already occurred. An electromagnetic pulse struck, particles collapsed, magnetic fields collided, and reconnected. If activation, fragmentation, or revelation was to occur, it has already happened. We now live in the aftermath, waiting to discover what it entails. Did the storm reveal the silhouette, exposing the structure beneath the comet's camouflage as energy particles stripped away surface layers? Did it activate dormant systems, launching technologies that had slept for millions of years? Or did it merely create stress for the natural comet predictably, showcasing a stunning spectacle of plasma physics that teaches us about solar-wind interaction but says nothing about intelligence beyond Earth? The most likely outcome is dull. 31. Atlas survived a coronal ejection with minor fragmentations or surface changes. The gas ejection speed temporarily increased, then stabilized, and life continues as before. The storm did not destroy the comet and did not activate hidden mechanisms because such mechanisms do not exist. Just ice, stone, and carbon compounds follow the laws of physics in an environment that has existed for billions of years, but hardly anything definite. And in the gap between the probable and the uncertain live all the conspiracy theories, hopes, and fears about what is really approaching us from the space between the stars. The storm may have already begun to tell us whether the 31 Atlas is alive, natural or artificial, a threat or an opportunity. We just don't know what answer we are getting, and whether someone with access to this answer will share it before the next crisis moment, because perigelium is approaching. At the end of October 2025, at the moment of closest approach to the sun, when temperatures peak and thermal stress is at its maximum, the 31 Atlases will either survive intact or not. The coronal mass ejection was a test. Perihelion is an exam, and if something within this dusty core awaits awakening, if there is even a drop of truth in speculations, rumors, leaks of images, and inexplicable chemistry, then the sun itself is about to provide energy levels that make a coronal mass ejection seem gentle compared to what awaits us. 31 Atlas descend into the furnace, and we all watch what will emerge on the other side. Part 6. Origin Beyond the Stars. Each object tells a story of where it came from, written in the language of trajectory and composition. For 31 Atlas, this story goes deeper than any comet we have studied before, perhaps in an era when the Milky Way was still young and our sun had not yet formed from collapsing molecular clouds. Trajectory. 31 Atlas is a standard technique in orbital mechanics. Take the current position and velocity of the object, reverse the equations of motion, and calculate backward in time to determine where it likely was in the past. For objects within the solar system, this method can show encounters with planets, close approaches to the Sun, or origins from specific regions of the asteroid belt or Kuiper belt. The mathematics here is quite simple, as gravitational forces mainly come from the Sun and possibly Jupiter. However, for interstellar objects, the reverse calculation becomes significantly more complex. It is necessary to consider the galactic gravitational fields, disturbances from encounters with stars accumulated over millions of years, even the gravitational influence of molecular clouds, and the distribution of dark matter. Uncertainties accumulate over time until the errors eventually surpass the galaxy itself, and you completely lose track. Nevertheless, researchers continue their attempts using the most precise trajectory measurements available and conducting simulations through models of galactic dynamics to determine the origin of the body known as Tri-I Atlas. Preliminary results published in preprint archives and awaiting review show something unexpected. 3-AI Atlas did not come from the galactic disk, the flat spiral structure where most stars rotate and where our solar system is located. Its trajectory seems to lead to a thick disk, a spherical collection of older stars, rotating at higher speeds and having more random orientations. The thick disk is ancient, populated by stars that formed when the galaxy was young, before the characteristic spiral structure fully developed. If Tri-I Atlas emerged from the thick disk's star population, the age-related consequences are astonishing. We may be dealing with material that is 7 to 8 billion years old, almost twice as old as our solar system. It is older than Earth, older than the Sun, formed when the universe was hardly half as old as it is now. This makes it the oldest solid object ever closely studied by humans. A time capsule from an era that we usually can only observe as distant light from remote galaxies. But here's the problem. Ice cannot exist for 8 billion years. Comets are fragile by cosmic standards, icy objects that gradually evaporate each time they approach heat sources or absorb stellar radiation while passing through star systems. Even in interstellar space, which is considered cold and protected, ice slowly sublimates under the influence of cosmic rays and the faint infrared glow of background starlight. Survival models of comets suggest that their lifespan is measured in hundreds of millions, at most a billion years in interstellar space, not billions of years. For Tri-I Atlas to still have ice after an 8 billion year journey, one of several unlikely circumstances is required. Perhaps he spent most of this time deep inside an ultra-cold molecular cloud, shielded from radiation and maintained at temperatures close to absolute zero, where the sublimation rate had dropped to nearly zero. Molecular clouds are giant formations stretching light years, and an object passing through one can experience millions of years of deep freeze before returning to open interstellar space. However, molecular clouds do not exist for billions of years either. They form, give birth to stars, and disperse over tens of millions of years. For the Atlas trio to remain frozen, it would need to somehow pass through several consecutive clouds, moving through the densest and coldest regions of the galaxy with astonishing precision. It is possible, but extremely unlikely, like winning the lottery several times in a row over geological time. Alternative explanations enter the realm of speculation. Perhaps the Atlas trio is not ancient at all, and its trajectory is incorrect. Restoring an orbit over billions of years involves many unknowns and approximations, making errors inevitable. Perhaps the origin from a thick disk structure is an artifact of imperfect modeling, and the object actually came from a much closer and younger place, simply having a trajectory reminiscent of ancient roots. Or maybe the trio of Atlas did not follow a natural trajectory at all. Perhaps they were guided. Galactic density waves offer a possible mechanism. The spiral arms of the Milky Way are not fixed structures but represent density waves spreading across the galactic disk. Regions where star formation occurs emerge as the wave pattern continues to swirl. These waves disrupt the orbits of stars, creating ripples that spread across hundreds of light years and persist for millions of years. Recent data from the Gaia spacecraft, which maps the position and speeds of stars with unprecedented accuracy, demonstrated these wave patterns in astonishing detail. Some researchers have hypothesized that sufficiently advanced civilizations might use these density waves as navigation aids, synchronizing their interstellar launches with galactic currents that naturally transport objects between star systems over millions of years. This is a space voyage using the gravitational equivalent of ocean currents to reduce energy costs for travel. An object launched into the right density wave at the right time could traverse vast distances with minimal propulsion, allowing galactic dynamics to do the heavy lifting. If the trio of Atlas rides the density waves, their arrival time was not a coincidence. It was calculated, perhaps millions or billions of years ago, to reach this specific area of the galaxy at this specific moment. The required precision seems impossible, but precision depends on patience. With enough time for micro adjustments and navigation systems capable of operating on geological timescales, it would theoretically be possible to maneuver an object through the galaxy using well-timed thrusts at strategic moments. This, of course, already borders on speculation, but speculation based on real physics. We know that density waves exist, and they influence the movement of stellar and interstellar material. Using them for navigation requires technologies and planning that significantly surpass all human achievements. But it does not need magic or faster-than-light travel, nor does it require breaking known laws of physics. The arrival time adds another layer of coincidence. 3 Atlas asteroids approach our solar system just as human civilization has developed technologies to detect and study interstellar objects. Several decades ago, we would not have noticed it until it passed perihelion when it was already leaving our system. And in a few decades, this suggests that we will live to see the moment when we can create better detection networks. The present moment is a brief window of opportunities and awareness. Is it a coincidence? For a naturally occurring object? Yes, undoubtedly. The universe is full of coincidences, considering how many possibilities exist. Throw enough darts randomly, and some will hit the target purely by chance. One interstellar object, appearing in the century of humanity's astronomical awakening, proves nothing but the existence of interstellar objects that occasionally pass through solar systems. The moment of truth approaches, and somewhere in the streams of data coming from telescopes around the world, there is either evidence or none to resolve the question of whether humanity is truly alone or if it has been visited by something ancient when our world was young. Part 7. Hidden Propulsion. Hidden. The search for artificial propulsion in the 3 AI's Atlas focuses on one key signal: unexplained acceleration, any change in speed that cannot be explained by gravitational forces or natural gas emissions from comet nuclei under solar heating. Every object moving in the solar system follows predictable trajectories determined by gravity. The sun attracts the most, planets cause disturbances, and even the mass of the asteroid belt has a slight influence on the trajectories. With sufficiently precise measurements and powerful computers, astronomers can model these gravitational effects and predict with astonishing accuracy where any object should be at any moment in time. When observations do not match predictions, something pushes the object in a way that gravity alone cannot explain. Oumuamua vividly demonstrated such an anomaly. As she left the solar system in early 2018, careful tracking showed that she was accelerating away from the sun faster than gravity could explain. The excess acceleration was small, measured in millions of fractions of a meter per second squared, but it was real and stable during several observations from different telescopes. Something was pushing Oumuamua, and the scientific community spent months discussing what it could be. The main natural explanation involved gas release, a process where frozen material on the surface of a comet absorbs solar heat, transitions from ice to gas, and is expelled into space. This ejection creates thrust based on the fundamental principles of rocket physics. Gas molecules rushing in one direction push an object in the opposite. Even slight ejection speeds can lead to noticeable acceleration over time, especially for small low-mass objects like Oumuamua. However, Oumuamua did not look like a comet. She had no visible coma, no tail of dust, and no obvious signs of active outgassing, even though she passed close enough to the sun that any ordinary comet would have been the center of attention. Exotic proposals were required to explain the observed acceleration solely due to the ejection, mainly focusing on water ice. This substance is so volatile and reflective that it could actively sublimate without leaving visible traces of dust or gas that we could detect. An alternative explanation proposed by some researchers more seriously, and by others less so, suggested artificial propulsion. Perhaps Oumuamua was a solar sail, a thin reflective sheet moving under solar pressure. Perhaps it was a malfunctioning spacecraft rotating in space and releasing fuel or volatile internal substances. Or it could be an active interstellar station using propulsion systems that we cannot recognize from external observations. Any of these options could lead to the unexplained acceleration consistent with the measured data. The scientific consensus settled on natural explanations, as extraordinary claims require extraordinary evidence, and the data on Oumuamua, while unusual, was not sufficient to justify the assumption of extraterrestrial technology. However, the debates left open questions and established a precedent. If another interstellar object shows similar acceleration anomalies, the artifact hypothesis will gain credibility through repeatability. Introducing the 3-eye atlas, approaching perihelion with trajectory data accumulating daily. Several research teams analyze positional measurements from telescopes around the world, comparing observed coordinates with gravitational models in search of deviations. The analysis continues, and the results remain preliminary, but rumors suggest that something interesting may emerge from the noise. Some researchers claim that the trajectory shows slight adjustments that do not correspond to purely gravitational motion minus speed changes that appear directed rather than random. These changes are tiny, within the margin of measurement error, which means they could be completely false, artifacts of imperfect observations rather than real physical effects. Or they could be real evidence of forces acting on the Tri-Eye Atlas beyond gravity and standard emissions. The energy costs for even small trajectory changes for a massive object are colossal. If the Tri-Eye Atlas really weighs billions of tons, as recent mass estimates suggest, altering its speed by even a few meters per second requires exerting force on that mass, according to Newton's third law. To create motion, it is necessary to use a reaction mass that is expelled in one direction, while the object moves in the opposite direction, or to influence something external using solar pressure, magnetic fields, or other natural forces. Gas emissions can provide natural movement, turning ice into expanding gas that creates thrust. In the case of the core of comet Tri-Eye Atlas, the observed gas ejection speeds could theoretically provide acceleration within a range that some researchers claim to observe in trajectory data. Mathematical calculations are correct if certain geometries and ejection efficiency are assumed, but in some analyses, the thrust direction seems incorrect, as if the thrust vector does not align with where the brightest ejection activity is concentrated. This discrepancy may not matter. The cores of comets are irregular bodies with complex surfaces, and gas emissions often occur from jets on the night side or from subsurface cavities, where the clear development of the coma is not visible. The fact that gas emissions are not obvious from ground observations does not mean they are not occurring intensely enough to affect the trajectory. We can observe exactly the pattern of acceleration that is expected from natural processes that are randomly positioned unfavorably for our observation, or we may see something entirely different. The search for signs of engine activity focuses on mission spectra, where ionized emissions or unusual chemical emissions that do not match typical comet gas emissions are sought. Natural emissions mainly consist of water vapor, carbon dioxide, carbon monoxide, and various organic molecules, all of which are well characterized spectroscopically. If Tri-Eye Atlas starts emitting xenon ions or metallic plasma or any other propellants used by humans in electric propulsion systems, it would be immediate proof of artificial systems. So far, no such signs have been publicly reported. Emission spectra show carbon dioxide, diatomic carbon, cyanogen, and nickel atoms, corresponding to the strange yet theoretically natural chemistry of comets. If there are functioning engines, they either use propellants we do not recognize, or their signatures are so subtle that they blend with natural gas emission patterns. Hybrid designs represent an intermediate variant between purely natural and purely artificial. Imagine a comet core that formed naturally millions or billions of years ago, then captured and altered by some technological civilization. They maintain ICX stereo as radiation protection and camouflage, but add internal systems, drives, and control mechanisms that can deliberately release gas to adjust the course. The appearance remains natural. The main composition corresponds to a comet, but the behavior slightly deviates from what purely natural processes would produce. This hybrid approach makes sense from an engineering perspective. Creating a spaceship from scratch requires immense resources and infrastructure. Capturing an existing comet and retrofitting it with minimal control systems using available materials provides better protection for sensitive payloads during interstellar travel. The camouflage of the comet is not a deception, but a practical engineering solution that uses natural structures for artificial purposes. Detecting such a hybrid would be nearly impossible through external observations alone. The mass mainly consists of natural ice and stone, so density measurements do not reveal small internal components. Gas release mainly occurs naturally, even if small amounts of gas are intentionally directed. The trajectory shows acceleration corresponding to gas emissions, even if its patterns are controlled rather than random. To capture the distinctive signs of intentional maneuvering, extremely precise measurements in several observational windows will be required. Some analysts claim to see such signs in the data on the trajectory of the Atlas trio. They point to correlations between changes in brightness, which may indicate gas release events, and subsequent changes in speed that seem optimized to maintain the trajectory. Correlations are weak and may be random, but they are present if noticed. Statistical significance remains on the edge. P-values fluctuate just above or below the threshold for claiming detection, depending on the analysis methods used. The scientific method requires caution when interpreting borderline data. Most anomalies appearing in preliminary data disappear with improved measurements and refined analysis. What looks like a signal often turns out to be noise, systematic errors, or data processing artifacts. Publishing statements about artificial propulsion based on weak statistical data can harm a career if subsequent observations do not confirm the results. But caution has another side. If true signatures of pull exist but remain subtle enough to hide within the margin of error, waiting for unequivocal evidence may lead to missing limited opportunities for gathering additional data while the object remains observable. By the time everyone agrees that the signal is real, the Atlas trio may have already passed perihelion and be striving back into interstellar space, becoming too dim and distant for detailed follow-up observations. This is where post-perihelion tracking becomes critically important. If the Atlas trio uses thrust, it will be most noticeable after perihelion, when solar heating decreases and the natural gas release speeds drop. Any continued acceleration during this period, when thermal forces diminish, will be harder to explain with natural causes. This is a scenario with irrefutable evidence, trajectory changes that persist when they shouldn't, indicating active control rather than a passive response to solar heating. The game of waiting continues. The perihelion will occur at the end of October 2025, followed by months of observations as the Atlas trio moves away from the Sun and back towards the outer solar system. If anomalies in acceleration arise during this period, the hypothesis about the artifact becomes much more convincing. If the acceleration stops precisely when the gas release is supposed to stop, a natural explanation remains in the foreground. Eighth part, inside the body. The question of what lies beneath the dusty exterior of 31 atlases leads us into a realm full of speculation, as we have almost no direct evidence of the internal structure, and we will not obtain it unless the object is destroyed or allows for some penetrating observation. Hypotheses about the broken body have circulated since the reflections on the unusual properties of the Oumuamua began. The concept is simple. If you build an interstellar probe designed to transport cargo across galactic distances, you do not make it solid. Solid bodies expend mass on a structure that serves no functional purpose. Instead, you assume internal voids that can hold equipment, tools, energy systems, or even biological cargo, protected from radiation and impacts by external shells. A hollow body could explain some observed anomalies. A lower average density than solid rock or ice aligns with mass estimates that seem high for the presumed volume. Unusual structural strength, allowing it to withstand thermal and mechanical loads that would have destroyed a loose debris mass. Strange acoustic or resonating properties, if someone could reflect radio signals from it with enough power to capture internal reflections, although such observations have not been publicly reported. One specific architectural concept that frequently arises in speculative discussions is the Dyson shard, not a complete Dyson sphere, but a fragment, a small part of an advanced megastructure, moving independently. The original concept of the Dyson sphere proposed surrounding entire stars with structures to collect energy, maximizing the available solar energy. Fragments of such structures, launched or broken off and moving through interstellar space, would be mostly hollow, thin shells optimized for surface area rather than mass. A Dyson shard crossing the solar system would look truly strange, too thin and too uniform to be a natural body, likely too reflective and less intentionally dust-covered for camouflage. 31. Atlas does not quite match this profile, but if you wrap a fragment in accumulated ice and dust from passing through molecular clouds, it could look like a comet until thermal stress or destruction reveals its artificial core. Speculations about exotic materials focus on carbon nanostructures, graphene films, buckyballs, and fullerene molecules. All those amazing materials that human materials science has discovered in laboratories but has not yet learned to produce on a megastructure scale. These materials have incredible strength-to-weight ratios, thermal properties that help withstand sharp temperature fluctuations, and chemical stability that allows them to potentially exist for billions of years while protected from oxidation and mechanical damage. Can such materials last for 8 billion years? Possibly. Carbon structures are chemically stable, and in the cold vacuum of interstellar space, destruction mechanisms are mainly limited to cosmic rays and random collisions with interstellar particles. With sufficient thickness and redundancy, accumulating damage does not necessarily threaten the overall structure. It resembles armor that slowly wears away, but continues to protect the inner elements until the goal is reached. Resistance to thermal loads becomes critically important during perihelion. Natural cometary ice cracks and disintegrates when temperature gradients become too extreme. The surface material, heated by sunlight while the interior remains frozen, creates mechanical stresses that exceed the strength of the material. If the 3 Atlas comets remain intact during perihelion, despite temperatures that would typically destroy comets, it indicates either an unusual composition or artificial enhancement. Hollow structures also provide an obvious volume for storing any cargo that the probe can carry. Instruments are efficiently packed into specially designed cavities. Energy systems, whether nuclear reactors or exotic alternatives, are located in compartments shielded from external observation. Biological materials, if that is what the mission is aimed at, occupy climate-controlled chambers maintained at a stable temperature regardless of external conditions. The idea of a hollow space within 3 Atlas also relates to hypotheses about modules and seeds that constantly arise in speculative discussions. If the object is not a single structure, but a vehicle containing several independent packages, then these packages need space for placement during the journey. The internal compartments, launch tubes, and deployment mechanisms require a volume that solid natural comets do not possess. But this is the complexity of all speculations about hollow bodies. We have no way to confirm this based on current observations. Gravity measurements could reveal density anomalies if we could place a probe in orbit around the 3 moons of Atlas, measuring how they gravitationally attract an orbital device and revealing the uneven distribution of mass. But we don't have an orbital device, and won't have one anytime soon. Radar observations could penetrate the surface layers and detect internal voids if we had sufficiently powerful transmitters and receivers positioned correctly. However, ground-based radar systems have a limited range and sensitivity for objects currently 3 AIs away. Fragmentation is the most likely path to revealing the internal structure. If stress during perihelion causes the destruction of 3 Atlas, fragments moving away from the core may reveal cross-sections showing the composition of the interior. Spectroscopy of fresh surfaces revealed by deceleration can detect materials not visible in the dusty outer layer. Visual imaging can capture geometries or structures that do not correspond to random cracks in natural ice. There are many natural explanations for hollow or porous structures, comets made of debris. Loose clusters of smaller fragments held together only by gravity can have porosity of up to 50%, meaning that half of the volume is empty space between the particles. This is not a cavity in the sense of specially created voids, but simply a loose packing of irregular pieces. Yet such structures create similar reductions in average density. Fragmentary clusters form naturally as a result of collision destruction and gravitational reaccumulation. Parent bodies, shattered by impacts that do not reach the escape velocity, allow fragments to regroup into loose conglomerates. This process is well documented for asteroids in the solar system and likely also applies to comets. The arrival of a fragmented comet from interstellar space is not unusual. It is simply a comet that survived the conditions of formation and was ejected on a trajectory of escape. However, the fragmentary clusters are fragile. They survive thanks to careful handling, avoiding high accelerations or tidal forces that could tear them apart. The 3-eyed Atlas experiences significant thermal stress during its approach to perihelion and survives a coronal mass ejection that should have destroyed any loose aggregates. If it remains intact after all this, then either it is not a fragmented mass or there is something holding it together besides gravity. A hybrid model, combining natural support with an artificial shell, continues to emerge as it solves several problems at once. Let's start with the natural core of the comet, providing mass and protection from radiation. We'll add internal reinforcements, possibly crystalline structures that grew in place, or mechanical support strategically placed to manage stress. We will wrap or cover with artificial materials that protect while maintaining a comet-like appearance. As a result, it will be something that is primarily natural, but improved to enhance survival and functionality. This approach reflects the philosophy of human engineering for spacecraft operating in extreme conditions. We do not create everything from scratch when natural materials work well. Radiation protection uses water or polyethylene, materials found in nature, but processed into useful forms. Structural components use aluminum or titanium, also natural elements that are processed and shaped. A sufficiently advanced civilization could do such things on a larger scale, using available comet cores as raw materials and adding minimal artificial structure where necessary. The real question about the internal structure is not only whether the three-eyed atlas is hollow or reinforced, or somehow artificial. The question is whether this object serves current purposes or ancient ones, whether we are observing an active probe on a mission or an abandoned artifact that managed to cross the galaxy but did not complete its task. If fragmentation occurs during perihelion passage and we are lucky enough to look inside this mysterious object, its internal structure may immediately reveal the scenario at play. Active systems appear organized, geometric, and purposeful. Failed systems appear degraded, damaged, and non-functional. Natural structures seem random, fractal, and geological. This distinction should be obvious if we ever manage to observe it directly. Meanwhile, the internal structure remains an ideal place for speculation. Inside, there could be anything: equipment, biology, empty space, or solid ice, and current observations cannot distinguish between these options. This simultaneously causes disappointment among scientists seeking answers and joy among those who prefer to leave questions open. We are quickly approaching the moment when some of these questions may be resolved, when thermal loads and solar radiation will test the three ocular atlases for durability, and it will either survive intact or shatter into informative pieces. The countdown to perihelion continues, with days left until maximum heating. Whatever secrets lie beneath this dusty shell, the sun will soon try to reveal them. And if it exposes an artificial structure, humanity will face an immediate question that has remained theoretical until now. What will we do when we finally get proof that we are not alone? Part 9. Conspiracies and silence. The gap between public statements and classified information creates ideal conditions for conspiracy theories, and the three-eye atlases have spawned more than their share in the last week since alleged sightings occurred during flybys past Mars. The viral version dominating social media focuses on a simple accusation: NASA is intentionally withholding images from Mars observations because they show what the public is not yet meant to see. The theory suggests that high-resolution photographs taken by a Martian reconnaissance satellite or other objects captured clear evidence of an artificial structure during flybys. The evidence is so unequivocal that standard explanations fail, and now the institutional authorities are deciding how to manage the disclosure of information to avoid mass panic. The changing explanations provided in official statements, initially blaming JPEG artifacts and then shifting to hot pixels and cosmic rays, appear suspicious as they seem like attempts to adapt rather than confident diagnostics. A true compression artifact would be obvious to image processing specialists working with these sensors daily and knowing how various error sources appear. The fact that explanations keep changing suggests that analysts are either unsure of their diagnosis or are seeking plausible stories that evade real observations. People often misinterpret absent data, and the archives of space mission data do not always contain successful observations. Tracking failures, guidance errors, timing issues, or instrument malfunctions can lead to unsuccessful observations that provide no useful data. When such failures occur, the obtained data files may not upload to public archives at all, creating suspicious gaps that actually reflect routine operational realities. But transparency is important for building trust. When agencies encounter failures in observations, Timely announcements and explanations prevent speculation that fills the information vacuum. Silence around Mars observation results breeds distrust, as it leaves room for imagination. A simple statement, for example, Mars Express tracking failed due to a guidance error, useful data not received, would immediately end speculation about this specific dataset. Accusations of withholding information and preventing panic are based on historical precedents that are more ambiguous than acknowledged by both supporters and critics. Do government agencies have classified data on potential contact with extraterrestrial civilizations? Probably in the sense that military and intelligence services are watching the sky and classifying information about sensor capabilities, regardless of what these sensors can detect. Secrecy protects methods, not goals, leaving opponents unaware of how good our tracking systems are, as information may be suppressed due to its connection with alien technologies. Public evidence of this is extremely weak or absent, mostly consisting of testimonies from people claiming to have inside information, but not providing documentation. Every major incident involving UFOs or unidentified aerial phenomena that was declassified ultimately turned out to be explained by something mundane: sensor artifacts, tests of classified aircraft, atmospheric phenomena, or misidentification of ordinary objects in unusual conditions. Secrecy would be expected if the confirmation of an interstellar object's existence occurred, at least initially. The consequences of a confirmed artificial interstellar object are enormous, affecting everything from scientific understanding to philosophical foundations and geopolitical stability. Responsible disclosure of information would require coordination among space agencies, governments, scientific organizations, and likely military and intelligence structures before public announcements. This coordination takes time, at least several days or weeks for something so significant. The example of classified object tracking by Oumuamua provides a vivid precedent. Months later, it became known that military space surveillance systems had been constantly monitoring Oumuamua, collecting trajectory data with higher precision than all available civilian astronomical observations. This data remained classified during the initial public discussions about the nature of the Moi mind, and was only declassified and published after the object had left the inner solar system. Why is the comet's trajectory data still classified? The official explanation is the need to protect monitoring capabilities so that adversaries do not learn how accurately American systems can track small objects at interplanetary distances. From a military perspective, this explanation makes sense. Space debris, satellites, potential weapons. All of this requires precise tracking, and revealing one's tracking accuracy could compromise defensive and offensive capabilities. However, the timing of the declassification and publication of data after the peak of public interest suggests another possibility. Perhaps the authorities wanted to observe how civil analysis would develop before introducing classified data that could change the direction of the investigation. Perhaps they conducted their own analysis separately, comparing results with civilian conclusions. Maybe they were just cautious with data from sensitive systems, following standard procedures regardless of the subject. Or perhaps they noticed something in this high-precision tracking that civilian telescopes did not capture, something concerning enough to remain silent until they understand what it means. The same pattern may repeat with the object Tri-Eye Atlas. Military space surveillance systems are undoubtedly tracking this object, likely with greater accuracy than civilian observatories. This tracking data is probably also classified for the same reasons as the data on Oumuamua. And if these classified data show trajectory anomalies more clearly than civilian measurements, we won't know about it until the authorities decide what we should know. Suspicions grow as silence fills the spaces where information should be. Nearly 2 weeks have passed since the flyby of Mars. During this time, no official processed images, scientific articles, or press releases announcing results have been published. The lack of information is striking, as this should be a scientifically interesting observation, whether the Tri-Eye Atlas is a natural or artificial object. Even the usual documentation of a close approach of an interstellar object deserves publication. A cynical interpretation suggests that data is cleaned before publication, interesting footage is removed, or edited to eliminate anomalies before the archive becomes available. This is technically simple with modern image processing tools. Remove some bright pixels, smooth geometric patterns, adjust the contrast to hide weak structures, and you transform an anomalous image into the mundane, leaving no obvious traces of manipulation. An optimistic interpretation of the situation suggests that processing complex data in the field of space science takes time, and we are still within normal operational timelines. Nothing malicious is happening. The scientists are just cautious and meticulous before presenting results that will be subjected to thorough scrutiny. Images will eventually appear, likely showing the usual view of a comet, while all supposed anomalies will turn out to be what official statements called artifacts and noise, not a signal. However, optimism requires trust, and trust is undermined with each day of uncertainty. The digital age has shaped expectations for instant access to information, making even reasonable delays seem suspicious, as we are accustomed to instant photo uploads, real-time video streaming, and immediate satisfaction of curiosity through search engines and social networks. When space agencies operate on traditional timelines measured in weeks rather than hours, it is perceived as a deliberate complication, even if it is actually routine procedure. The fundamental question behind all conspiracy theories is simple. If the 13th Atlas truly shows evidence of artificial origin, will NASA, ESA, or any military intelligence agency inform us if they have data confirming we are dealing with alien technology? And if they decide not to inform, at least not immediately, will this decision be justified? Arguments for controlled disclosure emphasize preventing panic, maintaining social stability, and allowing time for thorough analysis before announcing something that could change civilization. Arguments against secrecy emphasize democratic principles, the public's right to information, and the impossibility of keeping such secrets in the age of global communication and independent observation. Neither position is obviously wrong. Both reflect legitimate concerns about how humanity handles transformative information, and the tension between them creates fertile ground for conspiracy theories that fill knowledge gaps with speculation that cannot be definitively disproven until the original data becomes public. We are currently stuck in this interim, waiting for the publication of data that will either confirm or refute the speculations that have been accumulating since the first leaked images appeared online. The wait may end tomorrow, when a multitude of processed images with ordinary results are revealed. It can drag on for weeks while the bureaucracy goes through the verification processes, or it can last indefinitely if the data truly contains something the authorities have decided the public is not ready to see. The countdown continues, perihelion approaches, and in the absence of official answers, unofficial speculations fill all available communication channels with theories ranging from plausible to absurd, all vying for attention in an information environment where truth and fiction merge into indistinguishable noise. Part 10. Seeds and Swarms. The hypothesis that the 31st Atlas could carry payloads meant for deployment shifts the threat assessment from passive observation to active intervention. This fundamentally changes our perception of the presence of this object in our solar system. Scenarios with seeds of life start with the basics of biology and scale up to cosmic engineering. Life on Earth, despite its astonishing diversity, employs common molecular mechanisms indicating a shared origin. DNA uses the same genetic code across all domains, proteins fold using the same 20 amino acids, and cellular metabolism follows similar pathways. This uniqueness hints that the beginning of life can be a difficult step, while diversity, once set in motion, becomes inevitable, considering time and changes in the environment. If the origin of life is indeed difficult, requiring precise conditions and unlikely molecular coincidences, then a civilization that has learned to create or sustain life may see value in its deliberate spread, not necessarily out of altruism, but from some cosmic gardening impulse, sowing seeds in fertile soil and watching what will grow. The interstellar capsule with seeds will contain genetic material or self-replicating molecular machines packed for long-term survival and designed to activate when conditions indicate a suitable environment. When the 31st Atlas approaches a G-type star similar to our Sun and enters a planetary system showing spectroscopic biosignatures from an oxygen atmosphere on the third planet, it can be interpreted as time for deployment. The payload activates, possibly using the heat of perihelion as an energy source, and begins the release mechanism designed billions of years ago by beings long extinct or evolved beyond recognition. The delivery system can be as simple as the fragmentation of a comet. Thermal stress at perihelion cracks the core, embedded seed packets detach from the main body, and each fragment follows a slightly different trajectory determined by gas outflow and initial separation speed. Some fragments collide with planets, some end up in stable orbits, some completely leave the solar system. This scattering is like using a shotgun, low accuracy but reliable, requiring only careful initial design, or delivery can be targeted using engine systems to guide the fragments to specific destinations after separation. Mars attracted attention during the October flyby, possibly as reconnaissance to determine its suitability for planting. Earth will be within reach in weeks or months, depending on the orbital phase. The Moon, Venus, even asteroids or Jupiter's moons can carry useful payloads if the mission profile includes a comprehensive seeding action across the solar system, rather than focusing on individual targets. What will the seeds contain? The optimistic version includes simple organic molecules, amino acids, nucleotides, and lipids, the chemical building blocks necessary for life, but not life itself. These molecules, delivered to sterile worlds, could catalyze the emergence of local life, initiating biological evolution that would otherwise take billions of years. This is directed panspermia, not a random process, an intelligent design that does not require constant divine intervention. The moderate version suggests creating fully self-replicating systems, synthetic cells, or protein machines capable of reproduction and evolution. They will not possess intelligence. They are merely molecular machines following programmed tasks, yet by most definitions of intelligence, they will be considered alive. Under suitable conditions, they will reproduce, diversify, and ultimately evolve to a level of complexity that could lead to the emergence of intelligence, provided they have enough time. A civilization that sows does not control the outcome. It merely initiates the process and allows natural selection to guide development. On Earth, biology already exists, complicating any sowing scenarios. Introducing new organisms into an established ecosystem creates competition, predation, and potential collapse if newcomers lack natural limitations on their expansion. Invasive species on Earth demonstrate how destructive successful invaders can be to local biodiversity. An invasive species from another star system evolved under completely different selective pressures, and possibly using different biochemistry, could be catastrophically destructive or completely ineffective, instantly dying from oxidative stress or thermal shock, or from thousands of conditions that life on Earth takes for granted. Interstellar biology faces a huge problem. It must survive both in transit and when deployed in conditions that may be fundamentally incompatible with its requirements. The model of multi-phase invasion significantly increases the threat level, offering not seeds, but invasion forces. An organized deployment of technological or biological systems designed to establish control over encountered planetary systems. In this scenario, the Triple Intellect Atlas is not a single entity, but a mothership transporting several modules that detach during perihelion and pursue independent missions. The first phase involves reconnaissance, exploring the solar system to identify resources, threats, and points of interest. Passing by Mars serves this purpose. A close approach allows for detailed observation of the planet's conditions, atmospheric composition, surface features, and possibly discovering technological signatures indicating the presence of intelligent inhabitants. If civilization appears on Mars, various modules will be deployed, unlike if it turns out to be sterile. The second phase is activated based on reconnaissance results. Modules detach from the main body, each carrying specific cargo modules adapted for various tasks. Some can target resource-rich asteroids, creating infrastructure for mining and production using self-replicating machines. Some researchers may head to the moons of distant planets, establishing bases in radiation-protected underwater oceans. Others may strive for Earth, either to make contact with the discovered civilization or to neutralize potential threats before establishing their dominance. The third stage involves consolidation and expansion. Modules are coordinated to create infrastructure supporting a long-term presence. Communication networks are established, allowing separate units to exchange information and coordinate actions. Production capacities are increasing by using local materials to create additional modules beyond what was originally on the mothership. The population grows, whether it's biological organisms reproducing or machines self-replicating, until the invaders reach a sufficient number to accomplish their tasks. This scenario sounds like science fiction because it is science fiction, a speculative military analysis applied to an interstellar context with minimal connection to actual observations of the three-eyed atlas. But it is worth considering this, as the consequences of underestimating such scenarios can be catastrophic. If there is even the slightest chance that the three-eyed atlas represents a coordinated invasion rather than a passive natural object, then the appropriate response is radically different from scientific observation protocols. Scenarios with biological load raise other, equally alarming concerns. If the three-eyed atlas carries life, whether simple molecules or complex organisms, any pollution of Earth's biosphere could have irreversible consequences. There are quarantine protocols for returned samples from Mars, procedures designed to isolate unknown biology until safety tests confirm no threat. But these protocols assume controlled returns with materials in sealed containers, not comet fragments burning in the atmosphere and scattering debris across continents. If the three-eyed atlas truly carries an alien biochemistry using different genetic codes or alternative molecular mechanisms or exotic solvents instead of water, the contamination could be spontaneous. Alien biology simply cannot function in Earth's conditions, instantly perishing upon contact and posing no further threat. This is an optimistic scenario where biochemical incompatibility protects both biospheres from mutual destruction. The real threat may not lie in the three-eyed atlas, massive and conspicuous, tracked by every large telescope. The real threat lies in what he carries and releases, smaller objects that scatter in the darkness and carry out their individual missions while we focus on the mothership. By the time we understand what distribution has occurred, the scattered elements may already be established beyond our ability to detect or neutralize them. This is worst-case thinking, catastrophic scenario planning that responsible defense agencies conduct regardless of actual probability. The likelihood remains overwhelmingly high that the three-eyed atlas is just a comet. The light stripe on Mars turned out to be just an artifact, and no invasion or seeding is happening. However, the consequences of the mistake could be so serious that even unlikely scenarios require careful consideration and preparation. The period of perihelion is approaching. If the deployment of the modules happens, it will occur in the coming days. But if nothing happens, if the three-eyed atlas passes perihelion and continues its movement without showing signs of fragment release or abnormal behavior, the speculations will gradually subside, and we will return to normal operations until the next interstellar visit, and the whole cycle will repeat. But this time, something different is felt. The accumulation of anomalies, the timeframes of observations, the institutional silence, all this suggests that something greater is happening than routine scientific work. Perhaps it's just a coincidence and a misinterpretation, or maybe we are witnessing the first steps of a meeting that will define the future of human civilizations more profoundly than any event in recorded history. Time is passing. Modules may already be activated, and we do not know what will happen next. Part 11. Galactic waves and the search for paths. The Milky Way is not static. This is a dynamic system filled with moving matter and energy, where invisible currents can transport objects across interstellar distances, just as ocean currents carry ships across earthly seas. Recent data from the spacecraft Gaia revealed these streams in unprecedented detail and opens intriguing possibilities about how the three-eyed atlas ended up at our door. Gaia measured over 1 billion stars with such precision that it allows not only to determine their location, but also to understand how they move. When these measurements are compiled into galactic maps, patterns begin to emerge. Stars do not revolve around the galactic center in perfect circles. They exhibit wave-like oscillations, ripples in the structure of the galaxy, spreading across thousands of light years. These density waves represent areas where matter temporarily accumulates before the wave pattern moves on, like traffic jams that persist even as individual cars pass through them. The formation of stars is concentrated in density waves, where gas clouds compress to critical densities. Spiral arms outline these waves, marking places where stars and nebulae accumulate more densely than average. But density waves also affect stars and gas. They disrupt the movement of everything in their path, including dark comets drifting through interstellar space. An object passing through a density wave experiences enhanced gravitational forces that slightly alter its trajectory. For millions of years and through several wave crossings, these perturbations accumulate, leading to significant changes in course, guiding objects in predictable directions, even without any propulsion. Imagine it as gravitational surfing. Launch the object with an initial speed so that it intersects the upcoming density waves at optimal angles, and these waves will naturally guide the trajectory to your target. The control is smooth, yet persistent, requiring no fuel expenditure, only patience and precision at the moment of launch. For interstellar travel, which spans millions of years, such an approach seems quite reasonable, allowing galactic dynamics to do the heavy lifting while onboard systems conserve energy. Can the Tri-Eye Atlas object ride these waves? The restoration of the trajectory indicates a possible correspondence with known patterns of density waves, although uncertainties still remain significant. If the object originated from a population of thick disks, as some models suggest, it could have encountered many waves during its journey, each collision slightly altering its path until the accumulated adjustments directed it towards our solar system. The consequences of this are quite significant. If advanced civilizations understand galactic dynamics well enough to use density waves as navigational cues, then interstellar travel becomes more feasible. It doesn't take enormous energy expenditures to accelerate a payload to relativistic speeds. Sufficient thrust to achieve suitable wave-catching trajectories is enough, and then wait for the galaxy to carry your probe to its destination. This corresponds to the idea of temporal windows for alignment. Density waves rotate with predictable periods, creating bands of enhanced control that appear and disappear in regular cycles. The arrival of the 3 Atlas at the beginning of the 21st century, when human civilization was just beginning to develop detection capabilities, may represent such a temporal window. This is not a coincidence, but a calculation, a trajectory plan for intersecting with our solar system in an era defined by galactic orbital mechanics, millions or billions of years ago. The parallel with Polynesian navigation is more than just a metaphor. Pacific Islanders crossed thousands of miles of open ocean without tools, using wave patterns and subtle ecological cues to find tiny islands in the vast expanse. They worked with the ocean, reading currents to effectively steer their canoes. Galactic navigation may operate on similar principles, but on incredibly large scales, reading density waves to maneuver between star systems. If the use of waves is indeed possible, it raises questions about intent and randomness. Is the arrival of the Tri-Eye Atlas the result of purposeful navigation using understandable galactic dynamics, or is it a random trajectory that just coincided with the waves? This distinction is of immense importance. Purposeful arrival implies intelligence and planning, even if the planners are long dead. Random arrival implies nothing but random movement through a structured environment. Current observations cannot distinguish between these options. Unless 3-Eye Atlas shows clear course corrections during its approach, the navigation question will remain open. But if the use of waves is real, if density waves truly provide a structure for effective interstellar travel, then the universe becomes more interconnected than we imagined. Not emptiness, merely intersected by random events, but a network of paths connecting star systems and preserving their patterns throughout galactic time. Civilizations using these paths can send probes throughout the galaxy, not by brute force, but through the patient use of natural dynamics. This implies that the galaxy may already be saturated with probes moving along wave patterns, thousands or millions of objects crossing systems on trajectories calculated for maximum coverage with minimal energy expenditure. Most of them pass unnoticed through uninhabited systems. Sometimes one of them reaches a place where someone is watching, and we get cases like Oumuamua and Triangulum Atlas, brief glimpses of the constant flow moving through galactic space. Our position in the galaxy is unremarkable. About halfway from the center in the Orion arm, on a minor branch between the main spiral arms. Nothing in our location seems special from a navigational point of view, unless this unremarkable position is precisely that. The main areas of star formation in the spiral arms are chaotic, filled with supernovae and destructive radiation. Calm interfluvial areas like ours may be preferable as they are stable and offer better chances for fragile biological worlds to survive. A seeding campaign focused on life-bearing planets could concentrate on these quieter regions. The universe itself becomes a seed within this concept. Wave patterns transfer biological or technological packages between systems, distributing the fruits of successful civilizations across the galaxy over billions of years. Life on Earth may be one of the results of such seeding, although proving or disproving the origin of panspermia remains practically impossible without clear evidence of artificial design in our genetics. If the 3-Eye Atlas is part of this distribution network, moving through the waves and carrying seeds, its arrival does not signify special attention to Earth. We just happen to be in its path, one of many possible destinations. This is both reassuring and alarming. Reassuring because it indicates the absence of a deliberate threat. It is troubling because it means we are not unique, but just another potentially fertile spot in an ancient seeding operation in which we never consented to participate. The existence of navigation on a galactic level also answers questions about time. If wave routes determine time rather than rational signals, then the arrival of Tri-Eye Atlas is fixed by orbital mechanics, not synchronized with the maturity of civilization. The Three-Eye Atlas arrives now, as the waves have brought it at this moment, not because someone was watching Earth, but this implies a lack of local adjustments. If the probe sleeps for most of its journey but activates as it approaches solar systems, it can make final adjustments to its trajectory to optimize the approach geometry for its mission. A Martian flyby can become such a change, using gravitational acceleration or small maneuvers for more precise targeting of Earth than is possible only with a wave route. We observe space navigation in real time, if any of these assumptions turn out to be correct. A three-dimensional atlas, moving through galactic streams to a destination chosen billions of years ago, is now executing final maneuvers as humanity tries to understand what we see. The question is no longer whether we are alone in the universe. If there are probes using wave routes, if the galaxy contains navigation networks connecting star systems through accessible dynamic processes, then intelligence has spread through space for eternity. We are merely latecomers to a celebration that has been ongoing since the universe was young, and only now are we developing the technologies to notice that we are not the first guests. A critically important question remains. Are the other guests friendly, indifferent, or hostile? The same waves that carry the seeds of life can also transport weapons, surveillance systems, or simply scientific instruments. Until the three-dimensional atlas reveals more about its nature and purpose, we can only guess based on observed patterns and possibilities. Perry Hilly reflects on approaches that may bring revelations or disappointments depending on what the universe decides to show us. Waves continue their eternal cycle, ignoring whether anyone notices the paths they create in the darkness between the stars. Part 12. Organic Matter on Enceladus. While attention is focused on the three-dimensional atlas and its mysteries, another discovery made in September 2025 quietly changes our understanding of where life may exist and what it means for interstellar seeding scenarios. Saturn's moon Enceladus, long known for its subsurface ocean, has provided spectroscopic evidence of complex organic molecules, much more intricate than those previously discovered. The discovery was made possible by analyzing material ejected from the southern polar geysers of Enceladus, ice particles containing ocean water that overcame the moon's weak gravitational pull and spread across Saturn's rings. The Cassini mission extensively studied these geysers during several flybys from 2004 to 2017, discovering simple organic molecules, salts, and evidence of hydrothermal activity on the ocean floor. A new analysis using updated spectroscopic methods and improved calibration revealed the presence of amino acid precursors in the archival data from Cassini, complex carbon-nitrogen compounds that serve as building blocks for proteins. It is not the amino acids themselves, but molecules that are just one or two chemical steps away, suggesting that the chemistry of Enceladus's ocean creates conditions conducive to the natural synthesis of biochemically significant components. This confirms what astrobiologists suspected. Oceanic worlds throughout the solar system, and presumably across the galaxy, provide environments where the chemical prerequisites for life arise spontaneously. Europe, rotating around Jupiter, Titan, orbiting Saturn, as well as Ganymede and Callisto, and possibly several other moons, likely contain subsurface oceans with chemistry similar to Earth's. Oceanic worlds outnumber rocky planets with surface water, making them potentially the most common life-sustaining environment in the universe. If life easily emerges in oceanic worlds, and such worlds are common, then life itself becomes widespread in an extended sense. Intelligent life is not necessary, as the journey from simple chemistry to complex consciousness requires additional unlikely steps, but at least microbial life or its equivalent. The universe is filled with biology, much of which is hidden beneath icy shells, invisible to ground-based telescopes, waiting for any civilization advanced enough to break through kilometers of ice or collect samples from eruptions. This significantly increases the likelihood of probes capable of seeding life. If you are a civilization that has learned to create or accelerate the emergence of life and are looking for places to sow it, oceanic worlds become prime targets. They are abundant, stable, provide liquid water and chemical energy, and are protected from radiation that could harm fragile forms of early life. The placement of biological packages in oceanic worlds through impacts or intentional penetration makes strategic sense for maximizing successful seeding events. The Earth ceases to be unique in this concept, becoming just one of billions of potential habitats scattered across the galaxy. Three eyes of the Atlas arriving in a solar system containing several oceanic worlds can target these satellites instead of focusing solely on Earth. Mars attracted attention during the flyby, possibly because its geological past as an oceanic world is still reflected in the geological record. Europa is becoming an object of increased interest. Enceladus can receive a payload if the trajectory of the three-eye atlases allows for a close approach to Saturn. Enceladus serves as an example showing how the seeding process can work in practice. Eruptions from its surface already demonstrate that the material of the inner ocean naturally reaches space without the need for drilling. A probe arriving in the Saturn system could simply release biological packets in the emission areas, allowing natural processes to transfer material into orbit, where some of it would fall back to the surface. For thousands of years, some packets have been slipping through cracks in the ice into the ocean below, reaching a habitable environment without needing to land or penetrate the ice. This highlights how alien seeding strategies may differ from human assumptions. We imagine spacecraft landing on planets, deploying robotic landing modules, drilling routes, very straightforward approaches. But a civilization operating for millions of years may prefer passive strategies, releasing packages in positions where natural processes ultimately deliver them to their target locations. Patience eliminate the need for complex landing systems, allowing gravity and geology to do their work. If there is indeed life in the ocean of Enceladus that will be discovered during future missions aimed at more thorough study and analysis of material from geysers, the question arises, did this life originate independently, or was it brought from outside? The independent origin of life both on Earth and Enceladus will indicate that life arises easily, supporting the idea that the galaxy is abundant with biology. Origins brought from outside may be revealed through genetic analysis, showing too precise similarities to be explained by convergent evolution, proving that transfer between oceanic worlds occurs either naturally or artificially. The place of Earth in this biological cosmos is shifting from unique to ordinary participation. We are not the only living beings, possibly not even the first in our own solar system, if life on Enceladus emerged before life on Earth. The psychological impact of this realization manifests on several levels. It simultaneously diminishes the significance of a person while expanding the understanding of what biology represents on a cosmic scale. An atlas with three eyes, carrying seeds, becomes less shocking in a universe where oceanic worlds hide many potential habitats. Instead of questioning whether seeding occurs, the question becomes, how widely was it practiced, and did Earth participate? Did our planet receive visitors who brought biological packages that initiated or influenced evolution on Earth? Current data cannot answer this question, but a deeper understanding of early Earth conditions and improved biochemical analyses may ultimately reveal signs of external interference. This is related to the age and origin of the three-eyed atlas. Perhaps 8 billion years ago, a probe from the thick disk was launched by one of the first civilizations in the galaxy, beings that emerged when the universe was hardly half as old as it is now, and had reached technologies while most of our systems still lacked rocky planets. They could not visit Earth because it did not yet exist. However, they could send packages intended to activate upon encountering suitable systems billions of years later, preserving their biology on timescales that witnessed the rise and fall of countless subsequent civilizations. We may be descendants of the first intelligent life in the galaxy. The seed's children are so ancient that their original biology has evolved beyond recognition after billions of years of selection in diverse environments. Life on Earth may be one of the branches on a family tree that spans the Milky Way, connected to organisms in oceanic worlds throughout the galaxy through a common artificial origin. Or life on Earth can be completely independent, arising solely from terraformed chemistry without external interference. The universe is vast enough for both intertwined and independent origins to occur simultaneously, making the biology of any specific world ambiguous in isolation. Only by studying life on other planets and comparing it with earthly biology can we determine which scenario applies to us. The increase in organic matter on Enceladus does not prove that life could have been brought from outside. This only confirms that oceanic worlds are more biologically interesting than we assumed, raising the stakes for research and the likelihood of discovering life in other corners of the universe. The question of whether this life originated here or was brought from external sources remains open and requires data that we currently do not have. However, time suggests its nuances. Results from Enceladus were announced in September, and the comet Tri-I Atlas approaches perihelion in October. Both events occur simultaneously, creating a narrative connection, even if they are not physically related. We discover that there is more potential for life in our solar system just as an interstellar object, possibly carrying life, approaches its closest distance to the Sun. Coincidence, or merging, random timing, or somehow synchronized in ways we do not yet understand. The perihelion approaches, bringing answers or new questions depending on what Tri-I Atlas reveals. Enceladus waits beneath the rings of Saturn, geysers still erupting, the ocean bubbling, possibly harboring biology older than humanity, waiting for us to develop the technology to discover it. The solar system is more vibrant than we thought, full of possibilities and connections, less sterile isolation, and more cosmic intersections. Whether we like it or not, we are participants in processes that exceed the scales of planets or even stars, involved in galactic dynamics that existed long before the formation of our world. The only question is whether we are merely observers of these processes or intend to become active participants in what will happen next. Part 13. Comet Swan, 2025. R2. Cosmic coincidences continue to accumulate. At the end of September 2025, astronomy enthusiast Hiroshi Takahashi, using a solar wind tool available through citizen science programs, discovered another comet heading toward the inner solar system, designated C2025PU Swan according to standard nomenclature. Initial observations indicated a typical long-period comet from the Eddington cloud. Nothing unusual, except that any new comet piques the interest of astronomers. But when observatories around the world began tracking Swan R2, strange features emerged that echoed some of the more mysterious characteristics of Tri-I Atlas. The comet was developing faster than the models predicted. The brightness increased faster than usual for objects at such a distance from the Sun, indicating either an underestimated core size or unusually active gas emission. By early October, Swan R2 became visible in amateur telescopes, displaying a distinct green color reminiscent of the unusual glow of Tri-I Atlas. Green comets are not uncommon, as previously mentioned. Diatomic carbon typically causes such coloration. However, the appearance of two comets with bright green tails simultaneously within the same time frame crosses the boundaries of the ordinary and becomes statistically unlikely. Although it is not impossible, the chemistry of comets depends on their composition, which forms groups of informational regions. Therefore, several comets with similar sources may display unusual colors. Nevertheless, such a coincidence provokes interesting comparisons. The trajectory of Comet Swan R2 indicates the possibility of intersecting with material from meteor showers left by previous comets, creating opportunities to observe interactions of fragments from Earth. Some forecasts suggest that the tail of Swan R2 may pass through areas where meteors accumulate, such as the Taurids or Geminids, potentially leading to visible interactions as fresh cometary material mixes with old debris. Spectroscopic data from Swan R2 shows a predominance of carbon dioxide, reminiscent of three-eyed atlases, though less pronounced. There is also a sufficient amount of water vapor, but it is less noticeable, making the composition of the coma somewhat atypical for long-period comets. Again, this is not impossible, just unusual enough to draw attention. What makes Swan R2 particularly interesting to observers prone to conspiracy theories is the timing of its appearance. Two unusual comets approaching the inner part of the solar system simultaneously and displaying similar chemistry and green coloration arrive just a few weeks apart. This coincidence gives rise to speculations about coordinated arrivals, about multiple probing objects entering the solar system together as part of an organized campaign. The scientific community emphasizes that the Oort cloud constantly sends comets towards the Sun, and several dozen new discoveries occur each year, most of which are dim and unremarkable. Periodically, several bright comets appear at short intervals, which can only occur due to random clustering. The solar system experienced much more impressive comet shows in the past, such as in the 1990s, when the Hercules and Hale-Bopp comets were visible to the naked eye just weeks apart. However, Swan R2 is not just another comet from the Oort cloud in the same year as the three-eyed atlases. It is another unusual comet with chemical anomalies, appearing in the same month when the three-eyed atlases reach perihelion. Coincidence in time creates narrative connections that persist, even when scientific analysis claims that coincidence is the correct explanation. Speculators claim that this represents the arrival of a fleet, when several interstellar objects enter the solar system together, rather than as isolated travelers. In this scenario, the three-eyed atlases are just one element of a coordinated presence, while Swan R2 could be another probe or even a natural comet controlled by artificial systems. The entire inner solar system is under heightened scrutiny as something is happening, a galactic event or a decision of intelligence planning multiple appearances in this specific time frame. Scientists assert that the trajectory of the Swan R2 comet clearly points to the Oort cloud, rather than an interstellar origin, making it definitely a resident of the solar system. Unless conspiracy theories prove true, the trajectory reconstruction cannot be wrong, or the object did not spend time in the Oort cloud after arriving from interstellar space, making its nearest origin local, while its ultimate origin remains external. It is impossible to definitively prove that an object was not captured and brought into the orbits of the solar system if this capture occurred millions of years ago beyond observable horizons. The parallel between the glow of the Swan R2 comet and the light of the three-eyed atlases raises speculations about a common chemistry or engineering. If both objects are probes using similar propulsion technologies, surface coatings, or radiation signatures, they may appear similar from an external observer's perspective, despite being physically distinct entities. Standardization in probe design makes sense from an engineering perspective, as using proven technologies ensures repeatability instead of customizing each mission individually. Or the green glow means nothing but carbon chemistry, and we see only coincidences and random similarities. The same pattern recognition that makes us see faces in clouds or find conspiracies in unrelated events. The human mind beautifully finds connections, often too well, identifying correlations where there is only randomness. What could confirm the hypothesis of the flock? The discovery of additional objects with similar anomalies, too many to explain by coincidence, a clear connection or coordination among individual objects, changes in trajectory indicating mutual awareness and planning. The discovery of additional fragments or modules, separated from three-eyed atlases or Swan R2, showcasing artificial structures or capabilities. None of this has happened yet, leaving speculation in the realm of possibilities rather than evidence. Nevertheless, the question remains, why these two comets now? Statistical clustering occurs, random events are grouped by coincidence, but is this a complete explanation? If we saw 3, 4, or 5 unusual comets appearing in 1 month, would this exceed the threshold of coincidence and force us to acknowledge that something coordinated is happening? How many anomalies are needed before a natural explanation becomes less likely than an artificial one? We have not yet reached this with the Swan R2 comet and three-eyed atlases. We are still in the realm where traditional astronomy processes observations without mentioning alien probes, but we are closer than ever to the edge where extraordinary evidence meets extraordinary claims. The Swan R2 comet continues to approach, brighter than light as solar heating increases, developing its tail and coma according to the physical laws governing comet behavior. Observations continue. Spectra accumulate, trajectories are refined. In the end, we learn whether this comet will remain scientifically ordinary despite its external similarities to the three-eyed atlases, or if it will develop its own anomalies requiring explanation. The question keeps everyone on edge and sparks interest. Multiple anomalies, coincidence or not? Human psychology craves patterns and meanings. It struggles to accept that sometimes randomness leads to significant correlations. 2 green comets appearing simultaneously could be a mere coincidence or a signal that we are at the center of something larger than we realize. The perihelion for the three-eyed atlases approaches in just a few days. The Swan R2 comet will follow in a few weeks. If both objects behave normally during their upcoming approach to the Sun, showing standard comet evolution without anomalies except for initial chemical oddities, then natural explanations will prevail and speculations will quiet down. If one of the objects exhibits sharp, unexpected behavior, fragmentation revealing its structure, changes in trajectory, or module deployment, all other anomalies will be reconsidered in light of confirming the presence of something artificial. We wait and observe. Telescopes aimed at the sky, collecting photon signals that have traveled millions of kilometers to reach our senses, trying to decipher what these photons tell about the nature of reality and whether we are still alone in its perception. Part 14. Close encounters with asteroids. The sky is not only home to distant comets and interstellar visitors, but is also filled with rocks, thousands of near-Earth asteroids, whose orbits sometimes bring them too close to our planet. On October 10, 2025, one such asteroid designated 2025 TF passed by Earth at a distance of about 100,000 kilometers, closer than the orbit of the Moon, and well within the range of satellites. The asteroid was discovered only on October 9th, about 36 hours before its closest approach. It is not unusual for smaller asteroids, objects ranging from 10 to 30 meters, that do not reflect much sunlight and approach from directions where the solar glare makes them difficult to detect. The asteroid passed harmlessly, providing another data point about how many objects we do not see until they are practically at our doorstep. This detection gap becomes frightening when it comes to fragments of the three-eyed atlas. If an asteroid 10 meters in size can avoid detection until hours before its closest approach, how many smaller fragments could a three-eyed atlas release, leaving us no chance to notice? Objects ranging from 1 to 5 meters will be nearly invisible until they enter the atmosphere or collide with something too small and dark to be detected by modern observational telescopes. The community for planet protection has made significant progress in cataloging larger potentially hazardous asteroids, objects over 140 meters in diameter that could cause regional catastrophes. Existing studies have shown that over 90% of large asteroids near Earth have been detected, providing decades of warning about any major objects that could threaten cities. However, smaller objects remain largely undetected. The number of asteroids with a diameter of 10 meters crossing Earth's orbit is estimated in the millions, and only a tiny fraction of them are cataloged. Although such objects would not cause a global catastrophe upon collision, they could destroy entire areas, trigger tsunamis if they fall into the ocean, or create regional consequences, and we actually have no information about most of them until they are on a collision course with us. Here, the hypothesis about sleeping probes raises strategic concerns. If the three-eyed Atlas probe released small modules during its flyby of Mars or earlier, these modules may be following independent trajectories to Earth or other targets and remain invisible to current detection systems, waiting for a moment we cannot predict, as we are unaware of their existence. Modules do not need to be large to perform various tasks. An object with a diameter of 10 meters contains hundreds of tons of material, which is more than enough for complex payloads if the technology is advanced enough. Communication equipment, sensors, even self-replicating systems can fit into volumes that will be difficult for us to detect until they start functioning. Earth's orbit may already contain such objects that we are unaware of. A geostationary orbit at an altitude of 36,000 kilometers has thousands of active satellites, but observation of this area remains incomplete. Objects specifically designed for stealth, with minimal reflective capability and emissions, can hide among the debris and satellites that have already filled this orbital shell. The phrase, "what if one of them is already in orbit," triggers maximum paranoia because it's really hard to disprove. Space surveillance networks track objects large enough and reflective enough to be seen, but detection thresholds leave gaps. An object the size of a car or container, covered with radar-absorbing material, can remain undetected for a long time in busy orbital regions. The concepts of sleeping probes suggest a state of dormancy followed by activation upon certain triggers, allowing the object to remain inactive for months or years before suddenly turning on and executing programmed instructions. Detecting the object after activation becomes easier, as active systems generate electromagnetic radiation, but activation may also mean that the mission is already successful. This paranoia is not unfounded. This is a realistic assessment of the possible, considering the limits of detection and the potential capabilities of the opponent. If we are dealing with technologies of civilizations millions or billions of years more advanced, the assumption that they can hide small objects in near-Earth space is conservative, and the gap in politics becomes obvious. The planetary defense infrastructure focuses on natural threats, such as asteroids and comets, which move along predictable ballistic trajectories due to gravitational models. However, these systems are not designed to combat intellectual threats that can maneuver, coordinate actions, or apply countermeasures against detection and tracking. If we consider the three eyes of Atlas as an artificial system deploying modules, the existing infrastructure poorly matches the threat profile. The detection of deployment events requires continuous monitoring using sensors capable of capturing brief but powerful accelerations or fragment separations. Constant monitoring of expanded modules is necessary for volumes that are too large for current resources to cover in real time. We are not prepared for such a scenario not due to carelessness, but because preparing for every possible unlikely yet high-stakes risk exceeds available resources. Perhaps this calculation needs updating if observations continue to accumulate evidence of unusual visits. A mistake in attributing the 3 Atlas eyes to artificial origin can have catastrophic consequences if the modules are deployed while we ignore it. Risk assessment should lean towards caution when the symmetry of the threat is such. We must monitor the 3 eyes of Atlas more intensively, dedicating more time to telescopes and considering this as a potential first contact rather than routine astronomy. Even if the probability remains low, the scale of potential consequences justifies an enhanced response. It is unknown whether such a response occurs behind closed doors. Cosmic forces possess satellites with capabilities that are not disclosed to the public. If they are concerned about the eyes of Atlas, we will not know. Communication with observations of traces on Mars completes the circle of anxiety. If this trace was a module, and the 3 Atlas eyes deployed something during the flyby of Mars, then the operational phase has already begun. Perhaps more modules have since deployed, remaining invisible against the backdrop of stars, spreading through the inner solar system to various targets. We may be surrounded by probes that are watching us, systems are preparing for activation, and we are completely unaware of this, as our detection capabilities are not designed for such cases. The year 2025 reminded us that space is not empty, that objects constantly cross near Earth space, and detection is not guaranteed until collisions occur. If these objects become intelligent and numerous, if swarms unfold from motherships disguised as comets, the current defense systems offer almost zero protection. Time to improve these defense systems is running out, as they may soon be necessary. Perihelion arrives in a few days. The deployment of modules, if it occurs, will take place at perihelion, when available energy peaks and target positions are optimized. We are in a window of maximum threat. The days when deployment would become most likely, if it happens at all, are not far off. We mainly observe telescopes aimed at the sky, collecting data, analyzing images, waiting for what the universe will show us. Active defense requires threat recognition and acknowledgement that extraordinary measures are justified. We are not at that stage yet, still in the analysis phase where scientific caution prevails over the urgency of safety. Perhaps this is the right approach. Perhaps the 31 Atlas is just a comet, and all these fears are baseless paranoia caused by an overactive imagination and a lack of evidence. But perhaps we will soon learn that caution becomes catastrophic when it hinders preparation for threats that turn out to be real. Asteroids continue to approach, detected only with a delay, reminding us that dangers in the sky remain unseen until they are already here. It doesn't matter whether these dangers are stones or probes, natural or artificial, if we are equally unprepared for both options. Part 15. The final countdown. We have reached the end of this investigation, at least the end of what can be said before perihelion, when nature will force us to reveal its cards. This moment will come in a few days when 31 Atlas will pass the shortest distance from the sun and experience maximum thermal stress, maximum energy influx, the greatest potential for any revelation or disappointment that awaits us. Let's summarize. Mass estimates suggesting billions of tons may be natural, but they lead to the limits of what comets typically contain. The stability of the trajectory during interstellar travel requires an unlikely ecological history. Anomalies in images during flybys may be compression artifacts, but official explanations have constantly changed. Unusual chemistry with excess carbon dioxide and nickel goes beyond standard distributions. The green glow appears extraordinarily bright. Survivability during coronal mass ejections indicates structural resilience exceeding typical ruins. Possible trajectory adjustments reveal a geometry unsuitable for natural exit. The 8 billion year age implies an incredibly long survival of ice. The timing of arrival during a period when humanity can discover such objects seems suspicious. None of these anomalies alone proves artificial origin. Each has natural explanations that work if one accepts various unlikely but possible conditions. However, the cumulative weight of many anomalies occurring simultaneously creates a pattern that becomes harder to ignore. At some point, a natural explanation requiring 12 unlikely coincidences becomes less probable than an artificial explanation that requires only one, that 31 atlases are a probe. We have not yet reached this point for most scientists. The conservative assessment indicates that this is an interesting object worthy of detailed study, but there is no convincing evidence of artificial origin. The speculative assessment points to too many red flags to ignore. Both opinions have the right to exist, considering the available data. 3 timelines limit possible future scenarios. The timeline from hours to days will apply in case of dramatic changes during perihelion. Instantaneous disintegration revealing internal structure, sharp trajectory changes indicating engine activation, real-time deployment of modules, or communication signals using solar energy. If anything like this happens, humanity will learn within a few hours that we are dealing with an artifact. The timeline from a week to a month will be relevant if changes occur less noticeably. Analyzing the trajectory after perihelion, the time required to confirm anomalies, spectroscopy of fragments showing unusual composition, or expanded modules that will become detectable as they disperse. This timeline allows for scientific verification before public disclosure and institutional discussions on how to present the results. The timeline over a year or more will apply if nothing obvious happens. 3 and Atlas will pass perihelion and head back, displaying behavior characteristic of a natural comet. Speculations will gradually fade as new observations do not confirm the artifact hypothesis. This also includes the possibility of delayed activation, where the probes will wait months or years after perihelion before starting their operations. Each timeline is linked to specific triggers, such as the perihelion that will occur on October 28, 2025, when solar heating reaches its peak and thermal stress is maximized. The tail break or the release of fragments will become visible in a few days. Acceleration anomalies after perihelion will become apparent in a few weeks as trajectory data accumulates. It is important to realize that we are in a moment of waiting. This is not an analysis of historical events, but a real situation where each day brings new observations and potential revelations. Right now, telescopes are tracking Atlas. Right now, instruments are gathering spectra and images. Right now, something real is happening in the space between Mars and the Sun, and we are observing it. The worst-case scenario involves a swarm of modules deploying at perihelion, where dozens or hundreds of objects detach from the main core and head towards various targets within the inner solar system. The swarm quickly disperses, individual modules too small and dark to be reliably tracked, vanishing into the vastness of the solar system, executing programs defined millions or billions of years ago. The average scenario places 3 and Atlas in the role of an impressive comet, providing scientific data without existential threat. Unusual chemistry will help us learn about the interstellar environment of formation, and the release of fragments will allow for direct or spectroscopic assessment of internal composition. Nothing will fundamentally change in human civilization, except that we will learn more about how comets work. This is probably the most likely outcome, based on previous experiences with Umar Moore and Borisov, both of whom sparked speculation but ultimately turned out to be more mundane than unusual. The best outcome depends on the perspective. From a scientific perspective, the best scenario is an active probe ready for communication that provides direct information about its origin, creators, and mission. The first contact with extraterrestrial intelligence, even if that intelligence has been dead for millions of years. The acquired knowledge will revolutionize every field of science, from physics to philosophy. From a safety perspective, the ideal scenario is a natural comet confirmed by observations that rule out any speculation. The threat is eliminated, paranoia fades, resources are redirected to real problems. The main idea is that observation never stops. 3 and Atlas are not the last interstellar objects we will encounter. Observatory telescopes are improving. Detection capabilities are expanding, and future guests will arrive with increasing frequency. Each new object triggers cycles of speculation and analysis. A database is gradually formed that either confirms these objects are of natural origin or accumulates enough anomalies to prove artificial presence. We are part of something ancient, whether it be natural physical processes occurring over billions of years or a mind reaching across the galaxy to touch our world. The scale of this phenomenon is breathtaking, but the reality is felt right now. Right now in our sky, an object that has traveled unimaginable distances is passing by us, and we are able to witness this event. This alone is an outstanding achievement of humanity, regardless of what Tri-Eye Atlas ultimately turns out to be. 100 years ago, we hardly recognized the existence of other galaxies. 50 years ago, we never discovered interstellar objects. Today, we track them, analyze their composition, discuss their nature, and seriously consider the possibility that they may represent alien technologies. The concluding phrase raises the main question. If the rumors are true, how much time do we have left? The clock is already ticking. The situation demands attention, an awareness that a decision is approaching. Not sometime in an abstract future, but right now, this month, while you live your ordinary life, unaware that the cosmic dice have already been cast. Perhaps we have all the time in the world because Tri and Atlas are just a comet and there is no threat. Perhaps we have months or years until the deployed modules reach operational capability. Perhaps there is no time left. The modules are already in place and only waiting for the signal to activate. Uncertainty is the essence of the question. We do not know. Despite all our telescopes, analysis, and speculations, we sincerely do not know what Tri-Eye Atlas is or what will happen next. The universe is about to tell us about this, whether we are ready for it or not. The perigee arrives on October 28, 2025. The waiting ends. Truth, whatever it may be, begins to reveal itself in light and shadow, in interferences and spectra, in the presence or absence of signals we awaited. The clock is ticking. How much time do we have? Days until periapsis. Weeks until the completion of post-periapsis analysis. Months until the emergence of scientific consensus. Years until the next interstellar visitor arrives and the cycle repeats. Or perhaps we have no time at all, and everything will change before we can gaze at the night sky. Before anyone realizes that the rumors were true and the countdown ends, while we are still deciding whether to take it seriously. This object out there is moving, changing, approaching its moment of truth, while we are here, watching and waiting. It is interesting whether this will be the story that future generations remember as the moment when everything changed, or just another footnote in the long history of cosmic visitors who came and went, leaving behind only data and fading speculation. The answer will soon be known. The universe is about to speak. Whether we are ready to hear what it says is an entirely different question.